Okay, it's time to celebrate Earth Week with the buzz about bugs. When we first heard about this buzz about bugs, we saw this amazing chemical structure in the announcement. And we looked at that and we said, what is it? And then we looked it up online because it's easy to do that now. We just type in the formula. That happens to be C11 H8 and then N2O3S2, and it's Firefly Luciferin. It's the stuff that glows in bugs, in fireflies. Now, we don't see these here in California, but if you grew up in the Midwest, when it starts to get dark on a warm summer evening, they're everywhere. And they're turning their little lights on and off very mysteriously. So that's what I remember when I was growing up. But how does it work? Actually, chemists only found out in about the time I was going to grad school. They were starting to figure out how it works. It turns out that there's an enzyme that grabs onto this luciferin, and it grabs onto oxygen, and it catalyzes a reaction. And the reaction adds oxygen to this carbon-carbon bond here, which is at one end of the molecule. And it forms this ring, this very strange ring, with 2 carbons and 2 oxygens. That's called a dioxetane, and it's not stable. It breaks down, and it releases carbon dioxide, which you know is a stable molecule, and it releases the rest of the molecule, but in an excited state. That's what this little star here means. And then it gives off light. That's where the energy goes. So that's a pretty complicated reaction that biology has figured out, and there are actually many different creatures that do it. It's not just insects. It also happens in many deep sea creatures where they want to produce some light to attract fish or to scare them away. I don't know, but it's dark down there. Anyhow, they have different compounds similar to this but not identical, and they have similar enzymes, similar catalysts that can combine oxygen and make light. So we're going to do the same thing, but we're going to use a synthetic compound called luminol, and I don't have the structure for it right here, but it's a ring with a couple of nitrogens, and what happens in the luminol reaction, which you can see actually on the label of your kit if you really look carefully, is that oxygen replaces nitrogen in the ring, and that forms the same kind of dioxetane structure that breaks down. So it releases light. And what I've done here is I've set up an experiment where we can demonstrate this. And you'll be able to do the same thing if you have the kit that we were distributing with some of these reagents in it. But before I start, I'm going to put on my safety goggles, because that's what you do in the lab. You don't expect anything to go wrong, but it's just like getting in your car. You put on the seatbelt before you start. Okay, I have some luminol here. I'm going to dump it in this cup. I'm going to add some water and dissolve it. Now this luminol is actually mixed with sugar and also with a compound called sodium carbonate, which is making the solution a little bit basic. And that's necessary for this reaction to work properly. So I'm dissolving the luminol here in the water. And I see that it isn't all dissolved yet, so I'll keep stirring. Now the other thing we need to make this reaction work is actually a tiny bit of copper. In solution we have this blue copper sulfate, which we're just going to put like one little crystal into each of these containers where we're going to do the reaction. Because it doesn't take much. And that's going to activate the oxygen. Because we don't have an enzyme here to activate the oxygen to grab onto it and make this reaction go. So we're going to use a different kind of catalyst. We're going to use copper-2. We're going to use copper sulfate. And it's a blue compound that you might be familiar with if you use it to clean up an aquarium. It does kill bacteria and mold and so on. Okay, so here's my luminol solution, ready to go. And here's my copper sulfate, ready to go. And here's the oxidizing agent. So we're not going to use oxygen. We're going to use hydrogen peroxide, or we're going to use non-chlorine bleach, which is another kind of peroxide. It's actually perborate. Hydrogen peroxide is something you should have in your home, probably in your medicine cabinet, where you might have it handy if you need to wash your fingers or some place where you've cut yourself. It kills bugs also. You don't want to use copper sulfate because that's not good for you. So make sure if you're using copper sulfate in this experiment, you just use a small amount and you pour it down the drain and you wash your hands afterwards. And you should put on the goggles just in case. Okay, so I've dissolved my luminol. I've got my copper sulfate crystals ready to go, and I have my hydrogen peroxide solution ready to go with a dropper. And now I'm going to have to turn the lights off or you won't be able to see anything. And I'm going to also zoom in on the reaction so you can see it better. That looks about right. Okay, time to turn the lights down. Let's hope this works. Back. Okay, like I said, I'm going to take my luminol solution and I'm going to pour it into these two vials. And I hope you can see this. And now I'm going to add hydrogen peroxide to one of them. Yeah. And I'm going to add this perborate solution to the other. So it's a very fast reaction. It's over and it's gone. Now I have some luminol solution that I made up here earlier, so let's see what that does for us. Not so much happening there. Okay. Sorry I didn't have a more spectacular demonstration for you, but these are glow sticks that you can buy in the store. And you know how they work. You break open the inner capsule and it starts reacting with hydrogen peroxide, in fact. So that's a chemiluminescence reaction that we can make work every time because they've set it up right. Okay, hope you enjoyed that. Thanks for watching.